In this lesson, we are going to work on this Jupyter notebook, exploring Python packages for machine learning. Previously, we got introduced to NumPy library in Python, where you can work with the numerical computing using the NumPy functions and the library itself. And also we explored the library matplotlib, where you can do data visualization. You can create plots using your data. In this notebook, we will be exploring two very important libraries for your machine learning projects. The first one is pandas. We can recognize pandas as the library you can do the spreadsheet task you will be doing with Microsoft Excel or any other spreadsheet application in Python. Then the other library is scikit-learn, which is a library will be very important for your machine learning tasks. So you will be creating machine learning models, evaluating them, and pretty much all the machine learning workflow will be in scikit-learn, except the deep learning or deep neural network machine learning projects. For deep neural network works related projects, we will be using TensorFlow in this class. So you have two major libraries, TensorFlow and PyTorch. We can use in Python. So we'll be in this notebook, we will be exploring an example problem. So we will get to know that in a very short while. And then I will get you introduced to pandas library, how you can work with tabular data in pandas, and then how you can build a machine learning model, basic regression model or linear regression model you can build with scikit-learn. This will be a very introductory lesson. I'm not going to cover any deep level details about machine learning model building. I will not be following the exact same methods we will be using in our actual projects, but mostly what you will see in this lesson will be introductory lesson to get to know about these two libraries and what you can do with it. Okay, so this could be a motivation for most of you who are new to machine learning, and also you will get to know what is your roadmap ahead in your learning. Okay, so this notebook divided into two major sections. First part is to work with pandas, and the second part is to work with scikit-learn library. In the first part, I will get to introduce to some pandas functions, how we can deal with tabular data sets. And the second part, I will walk you through the steps of building machine learning model, and then you will get familiar with our next lessons as well. All right, so let's get started. So the problem, let's try to understand what is the problem we are dealing here. So you are hired by a car seller to build an application to predict car efficiency, which is miles per gallon, how many miles a car can drive per a gallon of fuel. Okay, so you wanted to build an application. If someone gave you attributes describing the car engine and its build, it should be able to predict what is the car miles per gallon, or in short form we will call MPG. So that's the problem you're going to solve. So why this car seller wanted to have you develop an application to do that? Otherwise, the car seller has to drive the car with a known amount of fuel, or keep track of fuel usage and drive some distances and do some experimentally measure what is the car mileage. So these are pretty old cars. They don't have sensors to gauge accurately the fuel amount, and also you don't have the car mileage, so miles per gallon tracker in your dashboard, so like newer cars has. Okay, so this is old car setup. So with this application, so what the car seller is trying to achieve is to save some money spent on fuel on testing this car miles per gallon, as well as you will avoid getting more extra mileage to the car, because to test this practically you need to drive the car. So here, if you can make some application and with accurate method to determine the car mileage, so this task will be much easier and cost saving. Just assume that's your problem in front of you. You are trying to solve this problem as a machine learning problem. In terms of data, assume you are provided a table containing attributes of different cars. We will get to know how many cars and more details about the data set, but you are provided with the data sets with some attributes. You can see those attributes in the diagram on screen. And then you will get the car efficiency. So historically, that car efficiencies were measured by someone. So that data you will be using to build your machine learning model to predict car mileage or a new car comes into this car cell. New car means old car, but coming to the car cell for the first time. Okay, so what are the attributes as you see in the diagram? There are some attributes related to the engine, number of cylinders in the engine, the displacement, horsepower, origin of the car, the manufacturer, and then the weight of the car, when the car is built, the model year, and the acceleration of the car. The acceleration means how much time or in seconds will take to accelerate the car from idle or 0 miles per hour to 60 miles per hour. Okay, so that's how the parameters, or those are the attributes you will have in this data set. Okay, so if you are familiar with cars and if you know these terms in terms of or if you are doing some mechanical engineering related work, you probably know that. If you're familiar with cars, you probably know what are the definitions, but I have them in terms of Wikipedia links. You can click on them and try and find out more details. So you can do a simple Google search. Okay. All right. So let's assume now you have the data set with you and you now understood the problem. So there are some assumptions in actual machine learning problem. We had to spend some time to go through this phase, but assume you already went through that. You had a good talk with your client or this car seller, and you got to know about the problem and what are the requirements. You now start working on the machine learning model building steps, right? You got your data as a CSV file. In this case, since we are doing like a study project, so we don't have the actual data, we don't have actual client, we just assume we have a client. So this is a made up story. So we got the data from UCI Machine Learning Repository. So that's a data set matching our sample program. If you go to this link, you can find it out. So you have the link in your notebook. You can click on the link. Then you get into the page of UCI Machine Learning Repository. You got introduced to this repository in our previous lessons. You can download or you can browse many different data sets you can use for your study projects. Okay, so there are plenty of data sets available. I highly encourage all of you to go and visit this page and then get to know about all their data sets. And you can find out data sets for regression type problems, classification problems, clustering problems, or what type of data you wanted to use, whether you wanted to use for an image classification problem, if you can download some image data. For some tabular data, you can download like this one, right? And you can select what type of data you want. And when you go to this page, I'm going to discuss about this data a little bit, because that will also be important for your future learning. So any data set you get, either for a study project or for actual work, you must have a good understanding of what data you will be dealing with, right? So of course you will be do some analysis later with the Python notebook we are going to go through today. But from the source itself, you need to read a little bit or get more information about the data you are handling, right? So assume this is the source you are getting. The UCI Machine Learning Repository is the source you are getting the data from. So from the source, you can also find out many details about the data set you're going to deal with, right? For example, so this source will tell you it has 398 number of instances, okay? And then it has attribute characteristics. So this will tell you what type of data you should expect, right? So you should expect in this data set categorical data as well as real. Real means the numeric data here. So in our previous lessons, we looked into different data types, as well as how we can categorize data or classify data into categorical and numeric. And within categorical, we discuss about many different types of data we will be using, and numeric, we discuss about discrete and continuous. In categorical, we discuss nominal, ordinal, and binary. So we went through a like very detailed discussion. By now, I hope you all have the understanding on those. So with that, So you know now we should expect both categorical and numerical data in this data set. And since this is an academic website, so it will tell you what type of problem you can use this data for. So you can use this data set for a sick regression problem. So you can try to build a machine learning model with a regression model. Okay, so this data set has some missing values according to the source, right? And some other information when the data set is donated to this repository, etc. Okay, so that's the first thing you should be looking for any data set from the source. You should have understanding. Main points are how many instances. If you're getting tabular data set, how many rows you should be expecting. And if you are getting a tabular data set, you should having to have an understanding of how many columns you should be expecting, because the size of the data or volume of the data will be very, very important to decide how you can approach to load this data into your systems and how you can handle them, right? So therefore, have some basic understanding before you start any work with it. And also you should have a at least basic understanding what type of data you will be dealing with, whether you have numeric data, you have categorical data, if you have string data, how big are they? So those are like some basic background understanding you should have. Okay, so I gave you some more details than what we should discuss in the notebook, because these things will be important for our future lessons. Okay, so that's the first thing you should look from the source. The second thing you should look from the source is what are the each data attributes tell you, right? So we have number of columns. So we now have number of columns is number of columns 9 according to the data source, but the mentioned like attributes is 8 because one of the attributes will be the target variable for regression problem. Okay, so any problem you're going to solve or any data work you will be dealing with, you should have some basic understanding about attributes. Okay, that brings your domain knowledge into the problem. If you don't have the domain knowledge, if you're working on a problem where you don't have the domain understanding, for example, if you're working on a healthcare application, you're not a person who learned about medical terms and healthcare related work, but you are just trained on machine learning, computer science, or any other field. So you should try to get some understanding of the domain as much as possible before you are attempting to solve the problem. Because that will be very important. For example, in this problem, we are dealing with cars, specifically some car engines, right? So we have some variables or the attributes relevant to the car engine properties of a car engine. And some of the terms will be you can get from the common sense, like weight, horsepower, you know that, right? So you should know from this data source, we have like 9 columns, and each column normally in the data source, when they provide the data, they will provide you the data definition of each column. Okay, so in this attribute information provided from the UCI Machine Repository web page, it only contains what type of data you will be expecting here, right? So for example, miles per gallon or mpg, you should be expecting continuous value. Cylinders, you should be expecting multi-valued discrete value. Okay, so you should know now the number of cylinders in car engine will be a discrete value. So you cannot have like number of cylinders, which is a countable value. You cannot have 1.5 cylinders in a car engine. All right. So the displacement is relevant to your car engine. So that brings a domain knowledge again. And it is related to the volume of each cylinder, and it should be a continuous value. And horsepower is a continuous value. Weight, of course, is a continuous value. Acceleration, so we all know from our common understanding, weight, acceleration, what are they? So they are continuous values. And model year and origin. So model year is a multi-value discrete. So you know year, you can have like year 2011, 2012. You cannot have 2011.5 as the year, right? You can give now a month and date, but you cannot have like a continuous value there. Origin is actually where this car made, and it's a multi-value discrete, so we don't know exactly what each value tells you. The values you will see like 1, 2, 3 like that. We have to find out what each number will tell you about the origin, right? But right now in the data set we have as a discrete value or numeric value. Car name here, it's a string value. You can consider it as a categorical value. We will find out some ways how we can get the string value to use in our work. All right, so now it's about the basic understanding of the data and data source. Please make sure in any data set we will be using in this lesson, you have to go to the source and make sure you properly understand, other than that you should not directly load the data set and doing the machine learning work or building models or trying to load into pandas and do some Python stuff right away. So you should not do that. That's not what we supposed to do in a real project. So we're supposed to first supposed to understand the data from the source and then from the data itself. All right, so that's the extra lesson for today. You can go to the link and try to read more about it. All right. So now let's come back to the Python part. So what we are trying to do here is to load the data set from the repository into Python. So here what I did was I downloaded the data set and did some data manipulation tasks to help you. Since this is an introductory lesson, I did some data manipulation and uploaded to the GitHub repository. So you can also get the data set from the same repository. I provide the link to you. So you can download, or in this notebook, you have the link itself. So what I would do here is, so this is my path to the file. So I will name it as file path, because that's more appropriate than file name. So if you're using a Jupyter notebook in your local computer, if you have this file downloaded, so you can have the path to your disk. So you can have C drive, and then you can go to your folder and you can get the file. So if you're directly downloading from online resource, you should get the direct link to your CSV file. So since we are downloading a CSV file here, you can have the file path like this. Okay. So what we are doing here is loading this file from this link or from this path, and then we are creating a data frame from the CSV file, right? So in pandas library, so let's go through the step by step. So what to do this task, what you should do first is to load pandas library. So like NumPy or matplotlib we explored in our previous lessons, you have to do like import pandas as PD. So PD it will be used as alias here. So from later onward we will call PD dot, that means that should come from pandas library. Okay, so let's try to execute that first. So now after executing this, your pandas library is loaded to your Python environment. So you can use it, use pandas functions and classes right away. Right now, we are at this code block, so we can execute. We can use the read CSV function. Remember this read CSV. So in pandas, you have different read functions or methods. Because data can exist not only in CSV files, but it can contain in an Excel file, it can contain in other file types. So let's try to explore that later after we load this file. I'll show you what other sources you can use to load data from into Python pandas DataFrame. We will look into that in a short while. Okay, so the first step is to load the data now. So I will execute this. This again, like this will use the pandas read CSV function, load the file from this path, and create a data frame called data. So now we have the data frame loaded, and we can look into the first 5 rows of this data frame. So I'm not going to do this in this code block. I will create a new code block and execute that later time. So let's execute the first one just to load the data. So it will simply load your CSV file into a pandas data frame. It doesn't do any other thing. So now you have a data frame object created. You remember Python, everything will be considered as an object. If you wanted to check what is the data type, so you all know by now what is the data type, how we can check the data type. So you can say type data. So the the data frame object is a data frame object from pandas. So this is a full path and full path to a data frame object or the class we created this object from. Okay, so now let's look at when you load the data set. So what are the things you should be doing? We will discuss in more details. You should be very curious about any data set you will be dealing with in your data science or machine learning work, right? Like you're trying to get introduced to a person for the first time. You were very curious about that person. You are trying to ask some questions and you are having some good conversation to get to know about both of you, each other, right? So like that, the data is not live as a person. You should be asking some good questions still to get to know about the data. Those questions should be able to explain what data is and what you can do with the data, right? So we will get to know in this lesson down in the notebook how you can do that task. But one of the first thing you should know, at least from to get the preview of your data, like the first appearance. So to do that, we can use a pandas function called head, right? So now the data frame object we created, data frame object can have functions and attributes or methods and attributes. So head is a function available in the data frame, which you can use to read first 5 rows in the data frame. So let's execute and see what we get. So once you execute the data.head, you will see first 5 rows available in the dataset. So this is your this is a part of your data frame. So, or we can call it a subset of your data frame, subset of rows from your data frame. So it will show you columns, right, and rows, the first 5 rows, of course. So now this will serve as a preview to your data. You will see how the data looks like in the table. Right? Before that, you don't know. You loaded the data frame, your data set into data frame, but you don't know how the data looks like. But right now you have a preview. So what you did was you call the head function. Okay, so this is about the head. So now think like you don't want to get the first 5 rows. You wanted to see the first 10 rows. You can provide a number here. So that by default, head will assume the number of rows should be written is 5. If you want to change it, you can make it 10. So now you see the first 10 rows. Okay. All right. So now let's look at another thing. Now you think you don't need the first 5 rows, but you need last 5 rows. So it's obvious or it's very intuitive in pandas. Instead of head, you will say tail. You say data.tail. It will give the last 5 rows by default. Same as the head function, you can specify number of rows to be written. I will use 8 at this time. This will give you last 8 rows. I hope you're now clear about using head and tail functions to get a data preview once you load the data set into CSV file into the data frame. All right. So let's try to go to some details about the columns. So you know now those columns we have miles per gallon, cylinders, displacement, horsepower, weight, acceleration, model year, origin, and car name, as we already noticed above. So we see some sample values, what type of values they should be expecting, right? You see some bigger values for weight, like in thousands, and horsepower, some less than 100, right? And displacement is around 140, 150. Have some low values as well. And number of cylinders, as expected, you cannot have like a number of cylinders greater than 10 if you have some domain understanding, but you see a small number. And origin, as we expected, 1, 2, and 3, right? The model year, that is the year with 2-digit year. So 1990, 1982, 1983, we will have that, but 82 is the value for the model year. And we have the car name. So we have something interesting we can do with the car name we will discuss later. Okay, so its car name is a string value. Here also you can see what are the values loaded as integers, what are the values loaded as a floating point number. Just in the preview. Yes, but we will look into them systematically or the programmatically, I say correct. All right, so if you wanted to look into each of the column names, and if you don't have the domain understanding, if you're curious about them, what is miles per gallon, what is the cylinders and displacement, horsepower, weight, you of course everyone knows about, and how the acceleration measured, right? So you can read more about it from the Wikipedia links. I highly encourage to do that, because again, that your domain understanding will bringing in your domain understanding will be very important, and you can build a better product, a better machine learning product, or complete your project very well if you have that, or if you bring in, if you don't have. Okay, so let's try to understand how we can interrogate your data frame to get to know about it better, right? So you now have a preview using the head and tail functions. We can look into more things, or we can learn more about the data set or data frame after we load into Python. Okay, so the question we can get into is, okay, we'll get into that, but let's try to get another two important things before we go into the questions part. Questions we should ask from the data, not from you. Okay, so we all familiar with Excel or any spreadsheet application, right? In a spreadsheet application, we have rows numbered with the numeric values, and columns numbered with the alphanumeric characters like A, B, C, D, like that, right? So you can refer into a cell by using those row column address. So you can call. So in a data frame, you noticed you are in this preview, the leftmost column is we call an index. So that a row index, if I say more specifically. And the header is a column header, so which contain a name of the column, right? Okay, so this row index and column headers or column names we can extract from a data frame object. So how we can get that? So if you say data frame, data, which is your data frame object, you say index dot index is an attribute will be taking out from your data frame object. So that will contain the index column. So by default, it will be written as an object. So let's try to execute and explain then. So it will return as an range index object. It will say what is the starting index and ending index, and what is the step size. If you wanted to convert into a list, so we learned about list conversion function called list. It's a base Python function we can use to convert this range index object into a proper list by using that. So the next line I executed, so you will see how it being converted into a list. If you wanted to return a list of indices from your data frame object, so you can do this to get the list. Okay, so there's another way you can do that. I will also add to this notebook. So you can say data dot index to list. This should also return you a list. Okay, so that's an alternative method. So data index. So this is how we return index object, range index object. You can convert into a list by calling the toList function, right? Keep remind yourself again, everything in pandas, so Python is an object. So range index is also an object. You can call its own function, right? Pandas data frame also has some functions, and this within pandas data frame, the index is also an object. It has its own functions. ToList will convert the range index object into a list. Okay, so let's try to understand now how we can retrieve the column names as a list. So if you call the data dot columns, so the columns is an attribute again in pandas data frame. This will return you a list of column names. It's also an index object. So if you this we can directly use as a list or an array. But if you wanted to make it explicitly convert into a list, so you can also say to list. So it will convert in. So yeah, so this one work. Yeah, this will convert into a list, or you can use the data.columns. Whatever written as data.columns, you can convert into a list using the list function. Okay, I hope all of you are clear now how you can get the column names and the the indices are from the our index column from the data frame. So now let's come to the questions you should ask from the data frame. This is how we can get to know the data, your data set better. How many rows or records? So we read that from the source before, but we should ask from the data set accurately. So sometimes the source will not tell you the real story. Sometimes when you are getting the data from source to our destination, which means our internal systems, we may lose some data. We may not have the exact data set described in the source documentation. So we should know that for sure. Sometimes that will be a problem. We need to diagnose that issue, and then we need to get the correct data set, or we had to check why we are missing some data rows, etc. And then number of columns. You should know you get all the columns you're supposed to get. Right, again, the same as the number of rows, you can have some like missing columns in the data transformation from one source to another, or when you are retrieve this from a different source location to your internal systems. And then we should get to know, like the good question to ask is what are the data types and data formats. So we know now data types and different ways you can represent data. So we should know clearly what are those in present in your data set. And then you can get some understanding about the data by studying data distribution, how the data is distributed. If they are numeric data, you can find out what are the data distributions look like. If they are categorical data, so you can get some counts. You can get some frequency tables created to get that done. Okay, so those are some good questions you can ask from data to get to know about your data set better. Okay, so then when we are dealing with the problem, the first part of the questions about the data we will complete during the pandas part in next few minutes. And then the last part, the problems we can ask about the problem itself, right? The questions we can ask about the problem itself, the machine learning problem. What type of machine learning problem we are trying to solve here, and what we are trying to what we are going to use as our features or x variables, and what is the target variable we are going to find out here, right? Or y variable. So we will discuss about these things in the scikit-learn part of this notebook. All right, so let's move on to the discussion on pandas data frame to get answers for the data questions, basic ones, right? So these are not only the question we should ask in a real project. Remember, this is an introductory lesson. We should be more familiar with other things we should ask from the data set. We'll do this extensively in our future lessons, but this one will give you some heads up for the introduction. The first question is, get to know your data size. You remember we used the numpy dot shape, a numpy function shape in arrays, right? So that gives you how many rows and how many columns in an array. So we use this with the matrices in the metrics lesson about learning about metrics, and then we used in numpy arrays. So if you okay, so the another thing I wanted to mention is in pandas data frames. So under the underlying Python library used in pandas data frame is numpy. So your columns and your entire data frame you can will run on numpy, right? So data frame object also has the attribute named shape, so will serve the same purpose as a numpy array. So data.shape will give you how many rows and how many columns you should be expecting in this data frame. Okay, so now we know we have 392 rows and 9 columns. The data source told us we have 398. So what happened here is when I get the data set and when I do some data manipulation, we are missing some rows from the data set. So we have 392. So this is what we have to deal with in the future. So in an actual project, I mentioned to you earlier, again, I will tell you. So you have to go back if the data source information and what you get is not matching. You should do a double check to make sure you have everything correct. Okay, so in this case, we will move forward with 392 rows and 9 columns we have in the data set we loaded. Okay, so we have got the answer for the first question. We should ask from the data. And now we can ask the second question. What are the data types we have in this data set, right? So how we can get that is using another attribute in pandas data frame, so which called d types. The d types attribute will give you your data type of each column. So what it is going to return to you this is where in pandas we call it a series, but it don't get confused right now if you're not familiar with pandas, but think it will return you column names and data type of each column. For example, mile per gallon is stored as a floating point number, 64-bit floating point number. Cylinders stored as 64-bit integer number. Like that, you can read what are the data types of each column. So one thing to note here is when you are loading a CSV file or many other data sources into Python, the pandas assume the highest possible data type. So the data type with the maximum width it can hold this value, right? So 64-bit is the maximum you can hold. The 64-bit floating point and 64-bit integer, you can store integers and floating point numbers in Python. So it assumes the maximum value. So what is the issue here? For example, number of cylinders, we clearly know that cannot expect a value greater than 10. So what is the range of int64? It's a really big number. You don't need to have int64 to store a value which only can contain a value between 1 to 10, right? So you can easily do with int8 or 8-bit integer number, so which you can store from -128 to +127. What is the issue now? It will consume for each value in your data frame, it will consume large amount of data storage, or your memory capacity will be occupied unnecessarily by having this largest possible data type. Later we will learn how we can convert this data type into a smaller data type, but we have to do some other work to decide what should be the appropriate data type, right? To save some memory, or to increase some performance in our work later, right? For example, cylinders from our domain understanding, so we can clearly know this can be converted into int8, but others we should do a careful examination on the data to make sure we are converting into correct data type to hold this number within the appropriate range. So we will get into that later, right? This is why it's very important to ask this question from your data. What are the data types? And so we'll get more into that later. And then combining these data types and data size and many other details. So we can use this function. So remember, this is a function. The previous two are just attributes. This function called info in your data frame object you can use to get full details about your data frame. So let's see. So if you call the info function, you will get the first information we wanted to ask from the data. We wanted to get to know from the data is how many rows. So it will tell you how many entries, 392 entries, and the indices start from 0 to 391. It will tell you that makes 392 entries, number of rows, and then it will also tell you number of columns, total 9 columns. And it will also give you a description of each column, including number of non-null values. Remember, if you have a null value present in your data set, so then you will see a value less than number of total rows in that column, right? So here we don't have a null value present because I did some manipulation from the original source. If you load the original source, you will see and some columns exist in your data set where the non-null values in those columns are less than total number of entries or total number of rows you should be expecting. Okay, so this will tell you how many non-null values. And then it will also give you the information about the data type of each column, like we got in the dtype attribute when we call the dtype attribute early. So those are the basic information you can get here. And then you will see like count of how many columns from each data type. So that's a summary, dtype summary. And another useful information about the memory footprint of your data frame. how much memory your data frame used from your RAM or your memory to hold this data. So that's also very important information you should know. So this is a relatively small data set, 392 rows. In some machine learning application, we have to deal with millions or billions of rows, right? So maybe like say like 50 million rows you have to load into your pandas data frame. Pandas is capable of handling it, but it will consume a lot of memory. You should know how much memory you will be using at this point. There are other ways to look into that, but from Python, you can just from within your notebook, you can find out how is the memory usage of your data set, right? Then you can decide whether I should put some extra effort reducing these data types of each column to make the memory usage down. So these things we can decide later. So we'll discuss this in extensively in a later time, but this notebook will will go through some basic understanding and some basic workflow to do those tasks. Okay, I hope you all are clear about this info function and what you can get from the info function in pandas data frame object. Okay, again, you can keep a reminder to yourself, data is our data frame, which we load CSV file into this data frame object. That CSV file contain this information about 392 cars. Okay, so now we are using the data frame object. Okay, so now we talked about the data frame a lot, right? So we talked about indices or index column and the columns you can extract, column names, and we know data frame is a two-dimensional data set, so you have rows and columns. If you wanted to take one column out of your data frame, so we will discuss in detail how you can slice a data frame. You can take a column, you can take a row, you can take a range of rows, you can take a range of columns out of from your data frame, like we discussed with NumPy arrays earlier. We will come into that discussion in our future lesson, but so this one I'm just going to introduce to another concept related to your data frame. We can take a column out of your data frame by calling the data within square brackets. You have to specify which column you wanted to take out. Say like in this case, I'm going to take the weight column out. When you take the column out from your data frame, so that column will get a special data type, or it will be a special, it will be an object. We call that object is a series. Remember, data frame object contains rows and columns. If you take one row out of your data frame object, that one column out of your data frame object, that column will be considered as a series. It's not a data frame anymore. It will be a series. Okay, so this is how you can take a column out of your data frame. A series can have like a length, so you can, it will also return what is the length, how many items in that series, and what is the data type. Series always associated with a data type, right, as a column, right? Okay, so that's about taking a column out of the data frame. So now let's look at some tasks we can do with it. So we now got some understanding about the size of your data frame and data types, and how many values you should be expecting, whether you have null values or not, what is the memory footprint of your data frame after loading. So now let's look at some data, right? Actual data contained in that data frame. So to do that, we can, before we going to do that, we need to do some pre-processing work. So here what I'm going to do is, I'm going to introduce to you how you can convert a data type from a data frame column, right? So cylinders, like we mentioned earlier, we would like to convert that cylinders data type from int64 to int8. So now you can look up what is int8 if you don't remember, or you don't know what it is. So and also look into the ranges of int8. So you can do that study yourself in a later time. But in this exercise, what we are trying to do is we will convert this number of cylinders into int8. Origin, we know it's only contain 1, 2, and 3. It can safely convert into int8. Model year, we can convert into int8 as well. because we don't have anything greater than 127 in this data set as the model here. Okay, so now let's try to do this conversion and then call that info function again and see what changes we made to the data frame. Again, to remind you all, the function to convert a data type, so the function name as type or as type, you first need to take a column out of your data frame. You can also apply this to your data frame, but it's always safe to do column by column unless you have a proper understanding of each column data type and whether you wanted to convert everything at once. So that's another thing you should be mindful. So here I'm doing conversion one column at a time. So we first take the column out. Each column should have the as type function. We provide the data type. We should be converting this column into int 8 in this case. If you want to convert a floating point number into float 32 from float 64, you can say float 32. If you want to convert into int 16 or int 32, you can also do that here. So, but we are converting all these three columns into int 8. So we'll discuss about the data type conversion in a later time. But now let's look into that. So when we convert these three columns into smaller with the integers, what changes it made? It of course changed the data type of these columns to int 8, cylinders, model here and origin. Okay. And also you will notice the memory usage is reduced, not very large amount. So 27 kilobytes to 19 kilobytes. It's not much, but it gave you some good reduction of your memory, right? So that you free out some memory at least. What happened here is int 64 will consume 8 times more than int 8 the memory usage, right? So that reduction is important if you are dealing with millions or billions of records, a large number of records. So that will be a huge amount of memory usage you're going to save for other work. All right, so that's about the conversion. I know now you have some understanding about that. So try to execute this data, this notebook by yourself. And if you would like, you can play with another data set. You can load another data set and practice the same thing. That's how you can learn. So not only listening to this lesson or just going through this notebook will help you. You have to practice. Practice will make you a better machine learning engineer, data scientist, or a person who is working with machine learning, like a better person working with machine learning, right? Better skilled person. Yes. All right. So then now let's look at another thing, how we can process car names to extract brand. So this is an interesting thing I wanted to get you introduced in early phase of learning machine learning. So one of the thing I mentioned to you earlier as well, you should be very curious about the data you are dealing with. In a typical project, we don't get the data. We don't always get the data in a clear form we expect. Means we are not getting the data we can use right away and build a machine learning model. Sometimes we have to do a lot of data transformations. We have to extract or we have to mine certain things from the data source you're receiving. Sometimes we need to process some string columns to extract some features out of it. This is a good example. So we have a column named car name. So nobody tell you in the data source from when they're providing you the data. So nobody told you, okay, so this car name, what it looks like. So you have to examine yourself. When you read it, you probably should understand. So I'm not asking you to read right now, but I will guide you through this process. So this car name, if you carefully look at some examples, car name will contain two parts. The first part, you can ask the question yourself, is the car brand or the manufacturer. And the second part is the car model, right? Toyota, Datsun, right? Datsun 210. And that could be the car model. And then Toyota. The first part is the brand or the manufacturer. Then Corolla 1200, Pontiac, Plymouth, AMC, Chevrolet, Mercury, Ford. They all are car brands or manufacturers, right? If you get a value in this car name column, you have to examine more samples. You will see each value will contain its first word as the car manufacturer. What you would think as a person who is going to build this machine learning model or a data scientist, you should naturally think, okay, can we extract something out of it will be useful in our model building process, or maybe can we use some variable or create some variable out of this? Yes, you should try at least. I mean, like the machine learning data science work, like we should do some experiments. We should try out things, right? So because the data is not readily available all the time to use right away. I mentioned multiple times. You have to do some work with the data, right? So that's one thing we want to get a better understanding, to bring in some domain knowledge, to explore the data, how to interrogate the data. Very hard to get something out of it. Okay, so before we discuss further, I forgot to introduce you this new function. The function is sample. So this sample is another useful function in a data frame object or in a series, same as the head and tail. Remember what the head function does? The head function will return you topmost rows. If you provide a number, it will provide topmost in number of rows. Or if you don't provide a number, it will give you top 5. Tail function will give you the last rows. Given the number, you get the number of rows at the last of the node data frame. If you don't provide a parameter, it will give you the last 5 rows. But head and tail. The sample is another useful function you can use, so which will return you a random sample of rows from your data set. If you call the sample function from a data frame, it will return you rows, right? Sample of rows. If you don't provide a number to this function as a parameter, it will return one row. If you say sample with empty parentheses, it will return you one row randomly selected from your data frame. If you're calling the sample function from your data frame object. If you're calling sample function from the data frame object, with given a number as a parameter, it will return number of rows you specify. For example, if you say 10, give me 10 randomly selected rows. That's what you're asking from the data frame object. So here we are not calling the data frame object sample function. We are calling the sample function from a series. We extracted a column out of the data frame, so which is the car name column, and I'm trying to get a sample of 10. Okay, I will execute this again. You will see what is going to happen. Pay attention. So when you execute again, it will pull another random sample, not the sample you got earlier. Now you have a different set of names because you pull a random sample of 10 for the second time. You can execute again. You get a different set. So why? So it always trying to pull a random sample. We learn about random sampling in our statistics lesson. So this is how we can get. If you wanted to get not 10, but if you wanted to get 5 rows randomly selected, this is what you get. If you don't provide any parameter, you get 1 row. If it is a series you are calling this sample from, so it will get 1 column value. Okay, so make a good use of random sample function. We will work with that function a lot in a later time, but so be familiar with it, right? Sample, head, and tail are 3 useful functions associated with data frame object or a series object, where you can get rows or values out of as you need. All right, so let's move on. So now we let's come back to the topic. So how we can process car name column to extract car brand or manufacturer. That's what we are trying to do here. So we are doing some feature engineering work. So if you're not familiar with the word feature engineering, don't worry, we will be discussing that in very detail. How we can manipulate the columns or features available in your data frame to create new features, or you can do some data extraction from the features. So here we are doing some data extraction type of work. Okay, so what we are trying to extract here, again, like this will be little advanced thing for those who are very new to Python or very new to pandas. Most of you, yes, I assume. But just pay attention to what I'm doing here. Later you will see how it happened and how we can use it again in a later time. So I will get you familiar with more exercises in a later time. But let's understand what is happening here and try to capture what our goal, which is to extract car brand or manufacturer from the car name. So how we can extract? We wanted to extract the first word from each value. So that's our goal. So how we do that? From car name column in pandas, so we can call this str we can call it we are calling a string object within the data frame. So we are considering this column as a string column. So we can call string functions out of each value, right? So string functions we briefly discussed in our lessons earlier. So you can find out length of the string. You can always do some other of string operations. We did not go to in very extensive detail, but string operations will also be important for you to learn. So we will cover some of them in our future lessons as well. So here I'm calling the function name split. So string function in Python called split. What that function does is split a string value. Now focus on, assume like we are talking about one value at a time. We are trying to split this string value by given character. So this character we are assuming is space. When you found there's the string contain a space character, so you are going to split that string into two parts or multiple parts given the space character. So the one is not relevant here. I will delete that. So if you apply this function on this string, what you will be returning is the first value you will return as the first word is Chevrolet. Second value we will return as Concords. Okay, so now we know we can split this string into multiple parts by presence of space value. Example, this one, it will return you 4 different values. The first value, second value, third value, fourth value, split by this. What you should get here, so you don't need to get all other values. What we are interested at, what is our goal again, remind yourself, what is our goal is to get the car brand. We know from our inspection, first word contains the car brand or the manufacturer. That's only we need. We don't need anything else. So now we have some understanding about lists and arrays, right? So what this string split returns you, a list of words. By now you should have some understanding what it returns you. It returns a list of words, and then it will give you a list. What you can do, you can get the first word out of it. To help you, those who are not very well familiar with the strings, I will help you to understand that. So let's take a string like this one. Okay, so I will make it a string object. So I will make it as a name, say name. I'll make it like a car name. So I will create this as a string. So this by now you know this is string value assigned to a variable. This is now a string variable. I can call the function name split. So here we don't need to call this str.split because this is already a string value or string variable. I'm asking Python to split this string using the space character. So how many words you should be expecting? 3 words, right? So let's see what we should get from this. So we get a list of 3 words. You split this one string into 3 items. It returns as list of 3 items. Each will contain a string as is a word, right? So you know now what this split actually does to each of these values present in the car name column. But if you wanted to get only the first value, which is the Ford in this case, what you should do, consider this as a list. We learn about the list indices. So how we can get the first item is put the zeroth index. or the first index is the number 0. We get the 4. If we do that for this data frame column or a series, right, we will get a new column out of it. So that column should only contain brand or car manufacturer. That new column I'm going to assign, or we're going to create a new column. This is how you can create a new column from your data frame. You're all familiar with Excel or any spreadsheet application. You can write an equation, or you can write a formula and create a new column based on values on other columns. You can add 2 columns. You can do many other formula to create a new column. Okay? So like this, pandas, you can create a new column by applying some operations on one column or multiple columns. We'll do a lot in our future lessons, but this is one example. We are extracting a value from a string and creating a new column, right, from the extracted values. Okay, so this is what it does. And then what we can do here is, let me put this to a new cell. I will give you a preview of what we should expect. So this will be helpful for you to understand. So I will call the function named head from this newly created column called brand. So let me execute this. So now you know what should be expected. We get a new column named brand, and it's assigned to your data frame. So now your data frame should have additional column, new column. That brand will contain car manufacturer or car brands. Okay, so we get the head, return first 5 rows, first 5 values of this column. Okay. So now we can use another new function you can learn, which is value counts. So what the value count does, it will basically return you a frequency table. If you're not familiar with frequency table, we can learn that in a later lesson when we are discussing exploratory data analysis. So basically it will give you for each brand how many counts of rows, so how many cars from each bands are here. Like, let's execute first and then discuss. This is the counts of cars per like a car brand. For like for Ford, we have 48 different cars in the data set. Chevrolet, we have 43. Plymouth, we have 31. Dodge, we have 28, like that. This value count function also we will be discussing in detail. We can use it in different ways to get our data analysis task, or in our attempts of getting a better understanding of the data. But this is the very basic introduction. So you can use the value count function without any parameters, which will return a frequency table, right? So this is useful. We know now we have some car brands like highly represented. Some of the car brands are not that represented in the data set, but at least we now extracted a feature from a string value. So that's a good learning for all of you. But in our lesson, we are not going to use this feature in the machine learning model building, but I introduced you as an exercise. You can follow, or you can understand what we should be doing in the future lessons. Okay. So now there's another piece to learn here. So we now have a car brand. So we know now this can be qualified as a categorical variable, right? Earlier it was just a string variable with different values, but now we can have like as a categorical variable properly. Pandas will give you another data type. Okay, give you a capability of using a data type called category. Okay, so like integers, floating point numbers. Category is a data type you can use to hold categorical data. If you hold a string data, I think I did not mention, but keep that in mind. I will go to the top of the notebook. You will notice the car name is a string column. So in pandas, string column considered as an object. Strings are considered as an object, and we know that in Python strings are objects, but in pandas it will show string values as object in terms of data type, right? So you'll see it everywhere in a string object. All right, so what we are trying to do here is we are going to convert this categorical variable brand. Right now it's stored as a string object, right? and that string object we wanted to convert into a proper categorical variable. So this is how we would do that. We call the same data type conversion function as type or as type. We give the type to be converted into is category, like int 8 we gave above. We convert into a categorical variable, proper categorical variable, the brand, and then we assign the result, a new column created from this expression, into a new column named brand cat. So just stand for brand category. Okay, so now we can do this operation. I don't want to show you the preview right now. You all know what you should be expecting. If you need it, you can try that in your own notebook, and then I will show you the value counts of each brand. It does not change anything. You don't see any difference between what you had before with the brand as a string value or brand cat as a categorical value. No changes, but internally it do a big change within. So let's see. If you go to data info again, so you will notice, if you call the data info function from your data frame object, you will notice a new two new variables were created. One is brand, which is an object, obviously it's a string. Brand cat, or categorical variable we created. Now we have the new data type presence in the data type list, which is category. Okay, so what it happens actually, to hold a categorical variable as a string, each value should contain a string value, which is, if you don't get it, so don't worry, we can discuss that later. You can ask me questions later. It will consume a lot of data space, because string is consists of characters. Each character will take maybe 16-bit or 8-bit, and a lot of memory usage for each string. So if you have millions of rows and each row contains some string, at least 2 characters, it will contain some gigabytes or megabytes of data to store that. But if you convert this into a categorical column, proper categorical column, it will create a map between each string to a numeric value, or like, I cannot say the pointer, this is not the proper word, but think like you have some map, your string value to a number. In the column, it stores a number like 1, 2, 3, 4. It always mapped to a string value, because in a categorical column, if you have millions of rows, if you have 3 unique categories only, so each category will be repeated hundreds of thousands of times, right? You don't need to hold the same string hundreds of thousands of times, because it consumes a lot of memory. Instead of that, you can have a small number, just 1, 2, 3, int 8 number, right? So it's 1 byte. Like that, you can save space, and your performance of your processing can be increased with these categorical columns. Therefore, it's a good idea to convert into categorical column. We don't have a way just to see the impact on this conversion, but if you can experiment with it with a string variable as a categorical column, as a string variable, what is the memory consumption, and if you convert into a proper categorical column, what is the memory reduction, or what is the advantage you can get. So you can, that's something you can do as an experimental step for you from your side. All right, so I hope you now understood like some basic stuff, how we can deal with the data frame object in pandas, treating with some data type conversions, and understanding the data set better, and to get some basic ideas. So now let's try to, all we did above is to prepare your data set for our analysis. So to get to know about the data now. So now we are actually going into the data and trying to explore what data is trying to tell us. Before we are trying to use it, we first need to know what data is trying to tell us, right? So there are many ways you can do that, but since this is a very introductory lesson, and things will be in very high level descriptions, right, for everyone to understand better. So let's try to get into that. So now everybody remember, we spent about an hour or a little more than that discussing the data frame object. I hope you all remember what we are trying to do here. What we are trying to do here is we are trying to solve a problem for a car seller. The car seller wanted to predict miles per gallon or car efficiency given other car attributes. The mainly attributes are relevant to the engine and made and weight, like two attributes we'll get to know again down there in the notebook. So now let's try to review the problem as a machine learning problem. So now you should have some basic understanding from our previous lessons how you can identify your features and target variable. Think now for a few seconds, or you can pause the session and then you can think and then try to resume. What are the features you will be using in this problem? Okay, what is the target variable you're going to you're looking for? Okay, think. So we'll get into that in a short while. All right. So before we are going into the machine learning, one of the most important thing you should be doing after we get to know about your data frame, we should do a descriptive statistics to know what data contains, what the data is going to tell us, right? So because we need to understand about the columns, much data in the each of the column better. So we discussed about descriptive statistics. What are the descriptive statistics we can do in a typical project or typical data related work. So basically, you can get the mean, standard deviation. You can get like a minimum and maximum values, and you can get the range from those, right? The maximum value minus minimum value will give you the range, right? And also we can study about the percentiles, right? 25th percentile, 50th percentile, 75th percentile, right? So you know from our statistics lesson, the 50th percentile is the median value. We learn about the median and mean. So we learn about presence of outliers, how the presence of outliers can affect the mean value. So those are some additional stuff I'm going to remind you here. But the pandas function called describe can do all these things without writing any other code for you, right? So you can write individual lines to get mean, median, standard deviation per column, but this will be like a one-line code. Just call the describe function from your data frame directly. It will give you the basic statistics you can get, or descriptive statistics you can get for each numeric column you have without doing any other thing, right? So you will see that you have the count of values, mean, standard deviation, minimum, 25th, 50th, 75th percentiles, and maximum value for each numeric column, right? Along from this output, you can find out many things about the data set and how data is distributed, right? What is the mean value you should be expecting? What is the standard deviation? Remember what the mean and standard deviation will tell you about the distribution. What is the middle value? You can either get mean or median, and then standard deviation will tell you how the data is spreaded. But keep that in mind, standard deviation alone will not tell you, it cannot compare two columns, right? The standard deviation for the miles per gallon is 7.8 and weight is 849. So you cannot say the spread is larger in weight than the miles per gallon. Make sure you either get the standard deviation divided by mean, or you have to just, you can visualize it, of course, you can see that. All right, so but we will discuss the exploratory data analysis in our future lesson in detail, how we can interpret this table, what are the things you can do with it to make some decisions about the variables we will be using, whether we should use the variable as it is or we should be using some transformations to those variables. So should we use the variable at all? Those are some of the things you can decide here as well. All right. So the one of the most important thing I wanted to highlight here is in this exercise, what we are doing, so get some idea about the range and the mean value and the middle value of your data frame. Okay. So now you have like some understanding how we can get the descriptive statistics for numeric values. But what happened to those non-numeric columns? We created brand column. We already had a column named car name. So what are those? So we don't have any statistics about them. So what you can get is you can get some idea about those columns using the describe function by passing the parameter value include. So we can pass this all as the value to the parameter include. It will give you all the columns including non-numeric columns in your describe output. So let's do that. So if you call the describe with the parameter value all, include parameter value, provide the value all, you will get the describe function also for non-numeric columns. So which is car name, brand, and brand output are our non-numeric columns. So what are the values you can get for those? So you get the count as the same as the numeric values, and apart from the numeric value, you get the three new things. Unique means how many unique values present in these columns. What is the topmost occurring value, and what is the frequency of the topmost occurring value? Okay. So those are three things you will get for non-numeric columns, considered as categorical columns by default. But in this case, car name, out of 392 instances or rows available in your data frame or data set, we have 301 unique values, right? So we learn about unique values when we are doing the set operations, right? So we learn how we can find out how many unique values using sets in Python. How many unique values present in a list or an array. By converting into a set, you can find out how many unique values, right? The underlying principle is here, like within the describe function, they use something like that. But the important thing for our discussion here is, out of the 392, we have 301 unique values. And what is the topmost occurring value is a Toyota Corolla. So we have 5 instances or 5 rows where the car name is Toyota Corolla. Okay, so now the question to you is, this 301 unique values, can we consider car name as a categorical column? Probably no. It's a string column, not a good categorical column to have like that large amount of different values or unique values. To qualify as a categorical column for a machine learning problem or for analysis work, we should have like a less number of unique values. So that's better compared to the total number of rows. And sometimes we need to do some transformation to make that happen. Some large number of categories we need to transform into so small number of categories by combining them. We will look into that in one of our next notebook or in our future lesson. So you will learn more about it. But some situations you have to deal with large number of categories anyways, if you have a large number of rows or some special situations, but you can try to get them down as much as possible. So one of our attempt we actually did is that, so extracting the brand as a category column. And what happened to the brand now? So now we have only 37 unique car brands out of the 392 total instances, right? So that's what we get from our data manipulation task, or the transforming car name into car brand by extracting values. So this is good enough to qualify as a categorical column later. But if you noticed above, we have some categories will only have like 1 or 2 cars. So those we need to do some other transformation, which I'm not going to discuss in this notebook. We have to go some extensive discussions. But we can assume like this as a categorical column, proper categorical column for this problem now, even though we are not going to use it in machine learning model building down. So we have the topmost occurring category for the brand is Ford. Number of instances for Ford brand has, or number of Ford cars we have in this data set is 48 out of 392. Okay, so now I hope you have a good understanding how to use the describe function to get descriptive statistics for both categorical and numeric columns. Okay, so let's move forward. So when we are dealing with data, so like you are trying to talk to a person, you ask some questions, right? So we ask several questions above from your data frame object. I always mention you are trying to have a good conversation with your data frame. So that's what we are doing almost all the time when we are dealing with data. You should ask some good questions to get answers, to get to know more about the data, right? Another way you can ask questions are writing queries. I think you all are familiar with SQL or SQL in database. So you wrote at least in your life, you wrote at least one query, one SQL query. Even if you don't, you know how to ask a question from someone or some system, right? For example, this is a question as a human we can ask from the data set. Or assume your data set is a person. You can ask, give me records where the brand is in this list. So what is this list? Ford, Chevrolet, Plymouth, Dodge, and Toyota. So what you are trying to get here, you're going to get records or rows from your data set from brands only in this list, right? So that's a question you can ask in a plain English, but this is the way you can put into a proper query in pandas. So this is query text. You can write like this. Brand. We learned about the function in, right? We learned about the function in our lesson about mathematics for machine learning. The brand in this one of these items or one of these strings, right? So if brand is Ford, brand is Chevrolet, brand is Plymouth, brand is Dodge, brand is Toyota, then only return those rows. Pandas has a useful function, another new function. Keep that in mind. You are learning many new functions in this notebook. Please try to practice with them, and those are very useful. Therefore, keep that in mind. At least remember those functions exist. You don't need to remember the function name and everything as you need to remember as it is, but you have to know like at least these type of functions exist. Later, if you when you need them, you can always go to the documentation, you can Google, you can find it out. But remember, the query function exists. You can use a query to get the data rows you need, right? So your need. So when you pass this query to the query function in your data frame, it will return a sample records. Or I cannot say like sample. Let's see the selected rows. Okay, so I will give a proper name. So selected rows. So selected rows based on this query will be your a new data frame object. The new data frame object is selected rows, will contain only the cars in these brands. So let's see. I only printed head, but you already see this in the car brand. We only contain of this. So if you can experiment with it and you can get the full output. I would do that anyways. I will print the full output of selected rows, but it will not print everything because you have like 175 rows uh, qualified under selected rows, and you will get some breaks of in the display. Therefore, you will get limited rows with the top 5 and last 5. But if you carefully examine, you only get the rows from these brands only. This is how we can write a query. You can write queries in many different ways. You can write some mathematical expressions, or say like value is greater displacement value greater give me all the records where displacement value greater than 300, or give me all the records where number of cylinders less than 4, so not less than 6. So you can write some mathematical expressions or the inequality expressions as a query text. So we will use that a lot in one of our future lesson. I mean, we are exploring data extensively, right? So this is just an introduction how we can write a query and how you can execute that query and get selected rows out of your data frame object. All right, I hope you all now have a better understanding of things you can do with the data frame. So you are building your knowledge little by little. So let's try to move on. Okay, so now let's go to another way of exploring your data. So we know now how we can query if you wanted to get a set of rows out. So now let's try to explore a column, right? So we can use the same thing to get some basic statistics, or we can get the descriptive statistics for a column as well, same as we did for the data frame above, the entire data frame. If you wanted to study a column at a time, what you would be doing is actually you're calling it a single variable, you're analyzing a single variable at a time. So we call it univariate analysis. Uni is one. So we can get the descriptive statistics for the column MPG. I don't need to introduce to the what about the statistics you get here, and also the values you know now very well. You get the mean, median, standard deviation, right? The median is 50th percentile, 25th percentile, 75th percentile. Also you can get maximum value. Okay, so you can get, so you can apply the same for the categorical column brand. You will get the count, unique values, and the top most value and its frequency. For if you apply describe function for a categorical column, right? So now you know how we can apply describe function for a numeric column as well as a categorical column. Okay, so now let's apply this to another column, which is a numeric column we should expect. So we know the number of cylinders is probably an integer column, so we can apply that. There you will find out how many cylinders with minimum, maximum, 50th percentile, which is median, and the mean value, etc. Right? This is you are going to study, or you're going to analyze one column at a time. This is one way you can do the univariate analysis, doing the descriptive statistics. Okay, so we learned that now for categorical columns and numerical columns. Another way we can study a single column using some graphical methods or doing some data visualization. You can also do the histogram by tabular form. So you can get the counts. You can convert in a numeric column into ranges. We will discuss this in a detail when we are doing the exploratory data analysis lesson. But this is just an introduction. Remember. In the visual form, you can convert your data frame, the column, a numeric column, into a histogram. So in pandas, you're learning a new function, another new one, function named plot. Remember now, in math, when we are learning matplotlib, we learn how to plot using matplotlib functions, right? So you should go back and review that lesson if you would forget that. Pandas library internally use matplotlib, but it will make it easier for you to do the data visualization task using data frames. You don't need to call matplotlib. You don't need to write a lengthy list of codes or lines of codes in your data analysis work, but you can simply call the plot function within a data frame or a column, and then you can plot. You can get the plot out of it. Here what we are doing is we are calling the plot function within a series. Remember this, when you are taking a data frame column out, so it will become a series. You can call plot function in both from both series object as well as data frame objects. So here I'm calling the plot function from the series which contain model year, and the plot function, you have to tell this plot function what type of plot you need to generate. There are many types of plots you can generate from your data. You can generate histograms, you can generate bar charts, you can generate scatter plots, right? You can generate line plots, pie charts, many different plots you learned previously. We will discuss some of them in detail in our exploratory data analysis lesson. But here, what we are trying to do is we are trying to generate a histogram. So how you can tell pandas plot function what type of plot you need to generate from a data frame or series column. You have to specify the parameter kind. Kind is a parameter, you say histogram. The value, provide the value histogram. If you want to generate a bar plot, you can say bar. If you generate a line plot, you can say line. Or if you want to generate a scatter plot, you can say scatter. We will see some different plots down in the notebook. The histogram, if you provide hist as the parameter value, it will generate a histogram of model year. So let's see how it displayed to you. Okay, so now you have the histogram generated from the pandas plot function. You have the frequency, you have the year, right? We will learn about many things, how we can get the histogram into a better use to make a prettier plot, but I will show you one thing here. You can specify how many bins you should be expecting. By default, it will divide your range of years from 70 to 82 is the range of years you will see from the uh, uh, if we can do this model here as well, so you can describe, and we can say the model here. Okay, so let's see the describe. So we have the minimum here is 70, maximum here is 82. So this is how we have to some quick data analysis tasks to done. So we have to do these things. So now you did not have this model here in this notebook, but I added a new data a code block, and then try quickly get the descriptive statistics for the column model here. And then we know 70 is the minimum and 82 is the maximum. By default, a histogram function use number of bins is 10. You will see 10 bins created. If you want to control that, if you wanted to have only 5 bins, you can control by providing the parameter bin to this histogram function. Okay, so this one is bins, not bins. But type in the parameter. So bins is the parameter name, and then it will convert your it will create a histogram with 5 different bins, divided your range of years from 70 to 82 into 5 bins, and get the count for each bin, which is the frequency display. Okay, so this is how you can get a histogram from a numeric column in your dataset. So now let's look at how we can generate a box plot. If you're not familiar with box plot, uh, we will learn again about this in a later time, but I will briefly describe what box plot will tell you. So let me execute this first, because it would be better if I explain you with the diagram. Okay, so this is what we actually get. I will first introduce you to the diagram, and I will tell you what the diagram will tell you as a graphical representation of your data, and then we can come back to how we can plot it. Okay. So in the descriptive statistics, so we are trying to get the box plot for the column weight. Okay, so if you remember the descriptive statistics we did for the weight, you can redo when you're trying out the notebook by yourself. We know the maximum value, minimum value, mean, and median. Okay, so to make it in the proper order, I will make the minimum to the top and maximum to the bottom. Makes much more sense, right? So the minimum value is 1613. Mean weight is 2977, median is 2803, and maximum weight is 5140. So this is what we have from the data. So this mean and median we can get. Okay, so now we know what are those values. We can print it, we can read the numbers, of course, yes, but how we can try to digest this in very quickly as human. It's always good to have an image representation of data. I hope you all heard the saying, okay, an image is better than 1,000 words. The same as the figure, right? If you wanted to convey a message from your data very quickly to an audience, any audience, if you convert into a proper data visualization, it will be much easier for them to give the message, to tell the story, than just throwing like tables and numbers around, right? So we have to do it as much as possible, but in this case also, when we are trying to analyze the data, it's better to understand the data by data visualization. Same as the tables, same as reading numbers, but data visualization will help us better to do that, our data analysis task as well. Okay, so these same numbers, how we can represent in a one figure. Okay, so this is called a box plot, because you see the box here, right? Yeah, you see the box in this plot, and then the box plot will give you minimum the information about the minimum value. So and sorry, this is a box, and these two lines, we call it a whiskers. So you have the top one and the bottom one. So two lines, in the black lines you can focus. You will get an idea about the minimum and maximum value from these two whiskers. Okay, you will see the minimum value is 1613. The value is somewhere here. When this is a, the scale is not big enough for you to read the exact values, but you have some approximate values. So this is the minimum value, and the maximum value of the weight is this 5140. You have that range now properly outlined in this diagram. Okay, and then what the box is going to tell you, we to do that, I would better give you the descriptive statistics for the weight column. So this is what you can do, this describe, or the describe function. You can have it with you when you're practicing. So what the box is going to tell you is the bottom line of this box, or bottom margin of the box, is 25th percentile. Okay, the top order, or this line, top line of the box, is 75th percentile. Okay, we now know two things in this descriptive statistics, or the four things: minimum, maximum, 25th percentile, and 75th percentile. And then focus on the green line here, right? The green line represents, can you imagine what it is? What the green line can tell you? I told you, these numbers you present in the descriptive statistics, we are going to convert into a figure, right? Or this plot. 50th percentile, or the median value, is represented by the green line. Okay, so see how convenient we can convert the numbers into a figure and then try to get some idea about what we are about this column. Okay, so then now we have some things we did not represent properly. So what is the value we did not represent? It's mean and standard deviation. So the mean value now, obvious, the green triangle represent the mean value. In the y scale is the weight, the mean weight is represented by the green triangle. Okay, so you see the mean value is slightly higher than the median weight in this data distribution. Okay, so we don't have a way to properly represent the standard deviation in this diagram, but you can have an idea about the spread of the data by the 25th, the separation of the 25th percentile and 75th percentile, or the size of this box. So the difference between 25th percentile and 75th percentile we call interquartile range, difference between the first quartile and the third quartile, right? 25th and 75th percentile. So this will give you some idea about the data spread, your box, and then you get the median value, you get the mean value, and you get the minimum and maximum values. You see now, the box plot will be a very useful tool to represent your data column, a numeric data column, and get some idea about the data distribution. So what else it can do? It can also show you if there are any outliers. We did not discuss properly what are the outliers, but in very brief, outliers are something for a numeric column, the value is significantly higher, means like much more higher than what you expect in a normal range. For example, I will give an example. If you expect an age column from people in your community, you should get like maybe age, you can, how much the maximum age can be, like maybe 120 years. So the minimum age should be 0, right, or 1. So you see in your column containing people age, you get 200 or maybe 500 for like 1 or 2 rows from thousands of rows, and maybe in the minimum value is -20. Those could be some data entry errors. Those could be some data collection errors, or maybe someone provide wrong value, or maybe a typo. Many things can happen, but those things can exist in your data. So if you have such significantly higher or significantly lower values, those will be considered as outliers. If you have such outliers present in your data set, box plot will highlight them. So it will represent by a dot in the scale, and then you will know there are outliers present in your data set. Box plot is a very useful tool you should be using in your future data analysis work. Okay, so now we have some understanding how we can connect our descriptive statistics to a visual representation by the box plot, and also how we can understand the data distribution by histograms, okay, as a visual form. So let's move forward. So now we draw a box plot for the weight column for your entire data set. So now you wanted to draw the box plot grouped by the car brand. So to do that, I'm selecting not all car brands available in our dataset. I am selecting the topmost 5 car brands. So I'm only creating box plot for those top 5 car brands: Ford, Chevrolet, Plymouth, Dodge, and Toyota. So I'm going to create the box plot group by brand. So sorry, I forgot to give the proper description about the box plot generation. I will do that now. Same as the histogram, so we call the plot function from the weight column, right? And we use the kind as the parameter. We pass the value box. Remember earlier we passed hist to get the histogram. So here we pass the parameter box, and we also pass another parameter called show means. So this parameter will allow you to see the mean value. Otherwise, if you don't provide this parameter, you will not see this green triangle in your box plot. You can have it without by setting it to false, or without having this parameter at all. This is how you can create box plot from any data frame column. Call the plot function, provide the kind as box, and if you wanted to see the mean value, you can say show means true. Okay, so now let's come back to our discussion on how you can create a box plot group by brand. So you are creating one box plot for the cars coming from each brand, right? So your Ford should have one box plot, Chevrolet should have one box plot, like that. So how you can do that? You have to call the box plot function. This is a new function, but it does the same thing as the plot function and creating the box plot. So this box plot function you are calling from the data frame object. Your data frame object is selected data. What we did was we write a query. It's the same query we wrote above. We execute this query and then create a new data frame, selected data which only contain cars from these 5 brands, and then we just make sure like we have that data frame created correct. We got the value counts by brand, so we have only those 5 types. So this is a verification step. And then we are creating the box plot for the selected data. We are calling the box plot function directly from the data frame. So now you don't need to provide the kind, because we are all directly calling the box plot function, not the plot function. Remember that distinction. And then we are saying the box plot function, which column, based on which column I should be generating the box plot. Based on, we have to provide the parameter column to this one, because we're going to generate a little complex box plot. You will see the output in a short while. We have to provide based on column is miles per gallon, and then miles per gallon by brand, right? So you can say brand, and then show. Okay, so first I will do weight. So I think I missed to copy this value here. So let's do the box plot miles per, not miles per gallon, weight by the brand. Okay, and show means true. Let's see, like execute and see. Okay, so now we have what it does. First does, it will get the selected data, new data, your data frame, group by the brand. So we will learn about group by. If you're familiar with the SQL or SQL queries, you wrote at least once a group by query. Group by is nothing but you are first grouping your data set by a categorical column, and then you are doing the descriptive statistics, or you're trying to analyze it based on the group. You're getting the mean value per group, minimum value per group, maximum value per group, standard deviation per group. You can do anything by group, right? So here, for the 48 cars from Ford, we are assuming we are doing the descriptive statistics only for the 48 group, 48 cars from Ford, and we are saying, okay, this is the descriptive statistic for those only for 48 cars. For Chevrolet, for those 43 class, like that. So here, each box plot you generate here for cars from each group or each car brand in this case. So you see the weight distribution is different. How is going to differ in each by each brand or car manufacturer, right? Some interesting stuff here. You see, in general, the Chevrolet, Dodge, Ford, Plymouth, so they have higher median weight, right? Relatively higher overall weight, those four brands, and the mean value also go close by to each other. But Toyota has lighter cars compared to these four brands. So this is kind of insights you can generate at least from this plot. Like, see how interesting looking at the data, and even before doing any machine learning work, so you learn something interesting, right, out of the data. So Toyota has a relatively low weight, so the car brand has to do something with the weight in this case, at least, right? And the data distribution also you can find out. So these forecasts, the distribution of, like, means like 25th, the difference between 25th percentile or 75th percentile or the interquartile range is larger for these four brands compared to Toyota. So the distribution of Toyota is narrower, and the other four is like wider compared to Toyota, right? Yeah, we can talk a lot about our data from this plot alone, but let's not spend a lot of time on this. You can come back to this in a later time, but you now have the understanding of what we can do with the box plot. How powerful is the box plot as a tool? And make sure you use this tool available in Pandas library, right? So this lesson is basically get you introduced to the box plot function. So let's, as another exercise, let's do the same thing. Let's see the miles per gallon by the car brand, how the box plot looks like. We have something, another interesting thing. Miles per gallon, the median miles per gallon, you see the green line, follow the green line in each box plot of these four car brands, the first four car brands, is lower compared to the median miles per gallon of Toyota cars. You can, I'm like, we cannot give a proper conclusion, but you can think of the Toyota cars are more energy efficient than the other four, at least from this data set. Keep that in mind. This is for this data set only. You cannot get anything out of the data set. If you are taking a conclusion out of this analysis, everything should be tied to this data set, right? So outside the outside understanding, you should not bring it here. So what you should be doing is you are doing from the data available to you with this data set. All right, so now we have a good understanding, I think, how to use box, how to interpret box plot. We will discuss in detail in a later lesson. All right, so so far we looked at how we can understand a variable individually or a column individually. Do the descriptive statistics, generate histograms, generate box plot, single variable at a time. The last box plot you generate, you can think of you're trying to analyze it in terms of two columns. You use the brand and the weight or miles per gallon. Yeah, so that's actually qualified to relationship between two variables. So that's we can fall it under the next topic as well. So this when you are trying to analyze the relationship between two variables, so we call it a bivariate analysis. Bi is two, right? And bivariate analysis will give you can understand the relationship between two variables. So what are the things you can do with those? You can in the visual forms, you can generate a scatter plot or line plots. So scatter plot is more appropriate in this case. We can generate a scatter plot to understand the data, look how the data looks like, how the data distributed for between cylinders and miles per gallon. So what is the relationship between those two data columns? Right, this miles per gallon is the relationship between miles per gallon with cylinders. Since we don't have like much finer range of cylinders, means like you don't have 3.5, 3.1, 4.5 like that. So you have discrete values 3, 4, 5, 7. So you don't see like a nice line or the data is distributed in a way you should expect. But you should understand like how the relationship looks like between number of cylinders and miles per gallon. Think like even it is not clear, what do you get out of this? So what things you can make as a conclusion by looking at the data set, right? So let's execute the next one and see what you can get from that. Okay, so this is the relationship between horsepower and miles per gallon. So what do you see here? What kind of conclusion you can make here just by looking at this plot? So when you increase horsepower, what is going to happen miles per gallon for the car efficiency? You will see a decreasing trend. Increasing horsepower will give you a trend of decreasing trend of miles per gallon or car efficiency. Remember, what we are trying to do here is we are trying to find the relationship between features and the target variable. What is our target variable now? I asked the question above. What is our target variable? Is what we are trying to predict. What we are trying to predict here, what the car sale owner wanted to predict is miles per gallon. Okay, so that's our target variable. So that's what we are trying to predict. Cylinders is one of our features we will be using to predict, right? That's why the cylinders become X and the miles per gallon become Y. Okay, so the question I asked earlier, so what kind of trend you will see here? You will see a decreasing trend when you increase number of cylinders, but not from 3 to 4. You see an increasing trend. This is like a very crude conclusion, but you can get some idea by visually inspecting this, right? So you see the decreasing trend when you're increasing the cylinders starting from cylinder 4 and go above. But in the horsepower, like miles per gallon versus horsepower scatter, you will see a decreasing trend. It's very clearly. So let's do the same thing for the weight. So when you increase weight, what's going to happen to the car efficiency? The same thing, like similar observation you will get. When you increase the weight of the car, your car efficiency will go down as well. This you can relate to your general understanding. So in physics, we know like to move something heavy, we need to consume more energy, right? We need more energy to push something heavy. So when you increase the weight, you need more energy to push your car, right? So it means you have to drive your car around with more weight. You need more energy. More energy should come from fuel. You need to have more fuel pumped into the car to drive or same distance. If the car weight is higher, you need more fuel. If the car weight is weight is lower, you probably need less fuel than the heavyweight car. That's from our domain understanding. But from the data, we can also get the same information. When we increase the weight, we get a decreasing trend of miles per gallon. Okay, so hope you all are clear with that. So let's do this the same analysis by the model year. So what happened in this case? So we are increasing the model year. We are not increasing, but we are seeing the pattern of changing the miles per gallon per model year. Here also you don't see a clear cut pattern like you see the horsepower and the weight, but you will see some increasing trend. Like think for a while, and when you look at it, if you take average miles per gallon by year, just as another crude analysis you can do, and then you will see an increasing trend. So now let's put some other domain knowledge or our general understanding. What is going to happen here? So what actually happened here? You can just assume from general understanding, we know when we build anything, not even cars. So when people learn about things, they do experiment, they do studies, they do research, and they make things better and better in the next version. So when you are thinking about a phone, we are thinking about computers. When we think about any product, so year by year they improve its quality, efficiency, and its features. Everything get improved, right? So what happened here could be from 1970s until 1982. So when the car manufacturer built new cars, so their engine is improved from one model to another by year, and then the efficiency also get improved. So more research being done and more energy efficient cars being made with the time, right? So that's why you see an increasing trend. That's what we can assume from the data, right? So we see the increasing trend when the model year is going higher and the miles per gallon is getting higher as well. Another thing, that's why I say, like, we cannot say exactly what is the reason. Another reason could be when the car is getting older, your efficiency is getting lower as well. Assume this data is taken at 1983. So your 1970 car is 13 years older. 1982 car is only 1 year older, running as new. So we don't know what exact reason, but what we can conclude from this data, we see when you have a newer car, you should have a higher miles per gallon, right? From the data. Keep that in mind. It's from the data. We can do this same thing, the scatter plot between displacement and miles per gallon. Again, it's a decreasing trend we find, and the acceleration with miles per gallon, it's not a clear trend, but we still have some clue to say it's an increasing trend. But data is scattered, not forming a like a linear or relationship or a clear trend, increasing trend, but you have like a slight increase in it. So now connect back to our learning about the statistics. If you get a correlation between any of these two variables, say miles per gallon with acceleration, or miles per gallon with weight, or miles per gallon with displacement, what you would be getting. So let's try to discuss that. So let's discuss with the horsepower and miles per gallon. So you will get horsepower increase, miles per gallon decrease. What should be the correlation, whether it's a negative or positive? Just think for a while. So when one variable increase, if the other variable decrease, we get it's a negative correlation. Okay, so we know that. Same for the weight and miles per gallon. Weight increase, miles per gallon decrease, we should get a negative correlation. So even without doing calculation, we can get that idea from this visual inspection. What if we do the correlation for the model year and miles per gallon? You should get a, when a model year increase, miles per gallon also increase, it's an increasing trend, should get a positive correlation. What happened to the displacement? Same as the other two above, you get the negative correlation when displacement increase, miles per gallon decrease. What if we get the correlation coefficient for the acceleration and the miles per gallon? What you should expect, whether it's a positive or negative? We should see a very weak correlation, but it should be a positive. You see some increase in trend, at least from the visual inspection. If you train your eye, you probably see it's an increase in trend, but it's not like highly correlated, but it should be weakly correlated. So previously we looked at the relationship between your target variable and feature variable at a time. So now let's look at relationship between two selected feature variables, right? So now first we will look at weight and acceleration. So weight and acceleration, we will get the weight and acceleration will be negatively or positively correlated from this inspection. We cannot say exactly how I can say it could be a negatively correlated, but let's see the actual correlation coefficient in data. Okay, so let's see another one, horsepower and acceleration. Okay, so this has some clear evidence to say horsepower and acceleration. When the horsepower increase, acceleration has a tendency to decrease, at least from the visual inspection. We should expect a negative correlation. Let's verify these things by taking the correlation coefficient. All right, so let's do the correlation coefficient first in the pandas data frame. You will learn a new function. So if you are using the pandas data frame to get a correlation coefficient, the function is CORR or core. This function will return you the correlation coefficient. We will learn more about this in another lesson, but this is the basic introduction, how you can get the correlation coefficient between each of these variables provided into the correlation function in pandas. There's another lesson you should get from here. If you are new to pandas, new to Python, what did we do here? We all know the data is our data frame object. It contains number of columns. We don't want to get the correlation coefficient between like all columns we have, so we wanted to select columns because for the display purpose, or if in your analysis you want to limit if you want to get the correlation coefficient, we wanted to limit set of columns at a time. So what we provided to this data frame object, we first part without this correlation function. So here what we did was we isolate a set of columns from a bigger data frame, right? So we could have like hundreds of columns in our data frame, but if we wanted to get only a selected columns, this is how we can do. We need to pass within square brackets as indices. We need to pass a list of column names. Those column names will only return when you call this data within square bracket. Within square bracket, you need to pass another list. List should be within square bracket as well. It will return only selected columns. This is what you get, and we are applying the correlation finally on that selected columns only. This is what we are doing, and let's try to execute. Okay, so now we get the correlation metrics. So let's try to read this correlation metrics very briefly. I'm not going to go into very detail. We are going to come back to this again when we are doing the exploratory data analysis lesson. So this correlation metrics, you have basically the same column names appear in both columns and both rows, and each cell value will tell you the correlation coefficient between the column name in your row and column name in the column of the returning data frame. Okay, so this basically return a data frame. Keep that in mind. Okay, so what is the diagonal? So now we have a better understanding about the matrices and the diagonal of a matrix. So diagonal of the correlation matrix will be the self correlation or the correlation with variable itself. It always 1, right? So when you increase miles per gallon, if you plot as both the x and y is miles per gallon, you get a straight line. There's no surprise there, right? The correlation with itself should be 1. Then the non-diagonal values will represent the correlation coefficient between the variable or the column in your row or the column in your and with the column in your columns in the correlation matrix, right? For example, the correlation between weight and miles per gallon is this value. Another important thing you learn about the matrix is the special type of matrix. We call it a symmetric matrix, where if you interchange rows and columns, nothing is going to change. The correlation matrix is a symmetric matrix. So if you wanted to get the correlation coefficient between weight and miles per gallon, you can either take this one or the one in the upper triangle. You all know this term as well, the upper triangle and lower triangle. To get a correlation values between two variables in your data set, you can either consider upper triangle or lower triangle. You don't need to have all don't need to scan all the values in the correlation matrix to do that. Okay. If you want to get the correlation metric between model year and miles per gallon, this is the correlation coefficient. And then between cylinders and this one. Okay, so let's try to verify what we see, what we saw in this visual representation is correct or not. So let's take one or two. So let's take one with a horsepower and miles per gallon. What is your conclusion? You should get a negative correlation. Okay, so horsepower and miles per gallon, keep that in mind. Yes, we get a negative correlation. Then let's look at another one. Let's look at what is the correlation between model year and the miles per gallon. Okay, model year and miles per gallon. What was our conclusion? We should see a positive correlation, right? To our human eye, we see a positive trend. We see the positive correlation. Let's see whether that is going to represent here as well. Model year and miles per gallon. Yeah, it's a positive correlation. It's much weaker, but it still show you a positive correlation, right? Positive 0.58. By the way, correlation coefficient should be a value between -1 and +1. Okay, and then let's look at another one. So now we looked at two examples with a variable or with a x value or feature with our target variable. Let's look at correlation coefficient between two features. So let's look at the correlation coefficient between weight and acceleration. Okay, so we don't see a clear cut information here we can extract about the correlation coefficient. I would say it's slightly negative, but let's see, let's verify with the correlation coefficient, weight and acceleration. Okay, so weight, let's take the lower triangle, weight rho and acceleration. Okay, so if you take the lower triangle, we can take the acceleration and weight, this value. It's slightly negative as we assumed, but it's much weaker, right? So it's -0.41. It's weaker when the value is close to 0. It's weaker correlation. When value close to -1, it's strongly negative, and the value close to +1 is like strongly positive correlation, right? This -41, still we have a negative trend, even we don't see in the visual form, right? Now let's look at the other one, horsepower and acceleration. So let's take the horsepower, let's take the acceleration from the row and the horsepower from the column. -68 is stronger than the correlation between the other two. We just looked at it, acceleration and the weight, but still it's a negative correlation. Okay, so what was the weakest correlation you find in this table? The weakest correlation I see here is -0.30, which is between model year and weight. So that's the weakest correlation. The strongest correlation is displacement and number of cylinders. Okay, so that's something important we should be discussing in a later time, how to decide whether we should consider like a variable to be removed or added. For the correlation coefficients, we can get some idea whether we should keep two variables in our features or not. For your understanding, what we are doing is like we are building a regression model. So we have to have some considerations we have to have in this model building about the variables. This kind of analysis will help us whether we should have those variables together in the variables in the feature set, build a regression model. All right, so I'm going to conclude this lesson at this point. We finished discussing about basic functions in pandas you can use in the data exploration, and do some basic analysis such as descriptive analytics, and then do some data visualization with pandas after loading the data, right? And to get to know about the pandas data frame, like such as how many rows, how many columns, data types, data type conversions, and how you can get some basic statistics from your data frame, right? So I hope you learned something good today, and please try to practice. The practice will make you a better, will give you a better grip to the pandas library, and then you can use it much better at your work, and then you will be a better person, a better skilled person in terms of machine learning if you to learn how to manipulate data better. Okay. So next lesson, we will discuss about the scikit-learn, how we can use the same data set we worked before in using pandas, and then we can use it to build a regression machine learning model using scikit-learn library. Okay, I hope this gives you some good introduction to all of you, and let's discuss about the machine learning model building in the next lesson. See you then.